Hello guys, in this video I would like to explain about drought characteristic in R and RStudio. We have done 3 videos before this video. The first video was about droughts, drought index, particularly that was SPEI. That's one of the the best drought index we can calculate. One of the best drought indices we can use to quantify droughts or drought events. And the main thing is it uses precipitation data as well as temperature data indirectly in the form of evapotranspiration. So that we call SPEI, standardized precipitation evapotranspiration index, SPEI. So this index uses both precipitation and temperature data, and that's why this better reflect the drought conditions. There are other indices like RDI, reconnaissance and drought index, and there are other index and indices like formal drought index, and one of the most famous SPI, standardized precipitation index. But the limitation of SPEI, standardized precipitation index, that's rely only on precipitation data. So in the region in the world where the temperature is higher, maybe SPI is not reflecting that. Maybe that's okay because there's less water, but precipitation temperature also have a role in the drought. Is a driver of the drought events. So in this video, I would like to explain about a drought characteristic, particularly extracting drought characteristic in R and RStudio. So once you have these characteristics, then you can analyze according to your project, your objective, or whatever assignment is assigned to you. So you can do that analysis, some future analysis or whatever. So we have done 3 videos. The first video was about drought index SPEI, and then that how to calculate SPEI in R and RStudio. And the third video was about drought characteristic. That was theoretical video. This was about the definitions and of the drought characteristic. This video is now in this video we will calculate drought characteristic from drought index, from the values of drought index in R and RStudio. The most important drought characteristics are frequency, duration, severity, intensity, and peak. And there are other additional drought characteristics as well, which we will cover in this video. So let's straight move to the R code, that how we can do this. And remember that we have done one video on calculating drought index SPEI in R, and this is now the repetition. So the link to those videos is given in the description of this video. To do all those 3 videos, and you can go and click on link to that, but those relevant videos, and you can see how what is meant by drought index SPEI, then how we can calculate SPEI in R and RStudio, and what are drought characteristics, how we can define drought characteristic. That will help you to understand this video, today video. And then I will have a video on calculating PET, evapotranspiration, by using different method like Drought method, and there are other method as well. So I will do that sometime, Okay, today video we are doing this with the generated data, but maybe you have your own data, so you can just use the same way like we are using generated data. You can use your own data. I will explain how. These are the 3 packages which we will use in this today video, because there are functions used from each of these. Okay, I already called these, and I remember that the link to the code of this video, the link to the R code of this video is given in the description of this video. So you can just go click and you will see the video. You will see the R code. You can change according to you. You can customize it, and you can use this R code to calculate SPEI, and then you can extract drought characteristic which you would like to use, which you would like to analyze, which you would like to investigate. Okay. So now you can this data, we generating data for the sample data preparation. The first step is, and we simulate sample data, replicate this with your actual data. Okay, you can replace this with your actual data. So you can we have data n underscore months, and it will save the data here. Like, okay, this is months, not the data, by the way. So month 240 month, that's mean 20 years of data. And SPEI underscore data frame, that is df. So that is equal to data dot frame, and it will create data date. This will create date from 2001 1st of January 2001, and that's by month, and length that out, that n months. So of course n month is 240, that will give you 20 years of data. Precipitation you can generate from gamma distribution. Remember that precipitation is positive skew distribution, and of course this can follow mostly gamma distribution, but you can use other distribution as well. So we are generating this data from gamma distribution. N months shape is 2. These are the parameters. Scale is 30, and simulate monthly rainfall. Okay, this will give you monthly rainfall data. This will give you 240 values, one value for each month in millimeter. And PET generated, this is generated from uniform distribution, R unif, n months, minimum 50 and maximum 150. From uniform distribution, you have two limits, A and B. So A is 50 and B is 150. So we are generating PET from this. Remember that when you are doing with your actual data, you need to have precipitation. You read the precipitation from CSV or Excel or any other file. That will be your precipitation data, the precipitation column. And PET you can calculate from temperature using different methods. So that will be replaced. This will be replaced by your actual data, precipitation and PET. So that's about data. Now calculate SPEI. So we can do like this. This is the water balance. Compute climate water balance. We have done this in the first video, so you need to watch those videos to understand this. This is the water balance. Just calculate this, and then calculate SPEI at 3-month scale. Okay, you can change it to 6 months, 12 months, or you can calculate as far as for 1 month. You need to change here. That scale is 3. If you want to calculate it for 1 month scale, you can use this one, like just 1, but I'm using 3 now, so you can use 3. You can use for 6, you can use for 12, 24, 48, and so on. So just calculate this, and that is SPEI underscore 3. That's mean this is for 3 months. Let's do it. Extract the fitted value SPEI value. So now, because you need to watch the first video, how this SPEI work. I have explained this theory in detail. So now we are extracting the SPEI values from the fitted. So extract the fitted SPEI values. So now we will have the SPEI values. Okay, now this have been done. Now extract drought characteristic. We have done 2 steps. One is data preparation, the other is calculating SPEI, and the third is drought characteristic. Extract drought characteristic, the third step. You need to define a function. This is the function. Define a function named get underscore drought underscore events, and this is the name of the function, and then the body of the function. This will give you like SPEI vector, and threshold is 1, -1 vj. Okay, if the value is less than equal to -1, we will say there is drought. If it is greater than this, we will say there is no drought, there are wet condition. And if it is less than equal to -1, we say there are dry condition, and there's droughts. By the way, you can remember that you can use any other threshold. Some people use -0.5, some people use -0.85, and some people use -1, and maybe some people using other lower value than this. Okay, so these are some of these droughts list. So define a function named get underscore drought underscore events, and then a flag indicating whether the function is currently inside a drought event, a drought period, and index when the drought started. Okay, so just need to run this. Okay, this whole function is running together, so I will explain this first, and then I will run. Okay, so we have done this, and then convert the input to numeric vector. So this is just converting to numeric vector. This SPEI underscore vector is converting. It convert this to just you can say and convert this to numeric values. Okay, L dot numeric. Loop through SPEI values. Now the loop start and this will create drought characteristic. Iterate over each value of SPEI vector using its index I. So this we can do like this. Start drought events. This will now start drought events. And a drought start F. We are not already in the drought, remember. The current SPEI value is not NA and the value is less than the threshold value, e.g. minus 1.0. We have defined, about that threshold. So you can change it and you will see, you can use that one. Okay, so a drought start F, these conditions are satisfied. Now, okay, drought end F. Now we need to stop the drought end when these conditions are satisfied. We are currently in drought and the current value is not NA and greater than equal to 0, i.e. no longer dry. Okay. And okay, this one, and you can use this one calculating the drought. You can extract all those values and finally return in the results. This will return the results of all those drought characteristics like start, end, duration, severity, intensity, and peak. All these drought characteristics will calculated by this function and this will return these values. Okay. Apply to SPEI 3 drought events. Okay, now these are get the drought events SPEI 3. Or at the end, you will see that you can display now the results. This line will give you SPEI values, current dot head. So top values of the SPEI values, and then this will print drought events. And this is, of course, this will have the drought characteristic, extracted drought characteristic and SPEI values. So you can see. And by the way, at the end, you can save this file to this file. Just remove this hash and then this will save this file, drought characteristic.csv. Okay. So I already run this until here, but still again, I will run this whole from here once again. Okay, that's worked fine. There's no error. Now I will display the results. Okay. Okay, now I will display the SPEI values. Just look at this. Yeah, these are the top 6 values. But if you like to see the dimension of this this file, you can see. Okay, SPEI underscore 3. Or you can write them here instead of. Okay, no. Okay, no, this one. This is actually the variable. So you can write them PIM and to this one. Okay, there are 2 faulty values because there are 2 faulty months. There are 2 faulty values and 5 columns. You can see again. You can see this one. You will see 5 columns. Just look at this. 1, 2, 3, 4, 5 columns. And now you can display drought characteristics. Just look at this. So very interesting. Okay, so just look at this. Yes, we have drought characteristic back here. Start, end, duration, severity, intensity, peak, start date, end date. Just look at this. The duration is 7 months. That means it starts from August 2000 and end in February 2001. So this means August, September, October, November, December, January, February. So 7 months, of course, 7 months duration. This is the severity. This is the intensity, peak, and start and end date. Remember that you need to watch the first video, the video which explain the theory of drought characteristics. Otherwise, you will be unable to understand what is meant by these drought characteristics. So this is the code, and the link to this code is available in the description of this video. So you can see and click and just download this code, customize this code account to your need, and then apply for your analysis. So this was all about drought characteristic. The previous video about the theory of the drought characteristic, and today I explained that how we can extract these drought characteristic in R and RStudio. So once you have these characteristics, then you can use in multiple ways for your research. Maybe you can use for return period calculation using 5 or 6 drought characteristic using Coppola model, and you can use all those together to calculate the return period in the future. Or maybe you can use machine learning model to predict these characteristics, or whatever you want you can do. It's depend on your objective and whatever assignment is assigned to you. So thank you very much, and I think this is enough for today, and see you in the next video. Ciao.